So the more you can do with these designs to keep them simple, well understood, give the contractor confidence that they can construct these, the better bet you're going to have to sort of minimize that quote unquote uncertainty factor.
In this episode, learn about Ascent, as of 2026, the world's tallest timber building, and the lessons learned that will let timber rise even higher in the future. Join Senior Principal Paul Becker and Vice President Kristina Rogers, both structural engineers based in Portland, Maine, as they talk with Jordan Komp about setting up tall mass timber for success.
Hello, everybody, and welcome to another episode of our Mass Timber podcast. I'm Paul Becker, and I'm joined by my colleague, Kristina Rogers. Kristina, how are you doing today?
Great. Looking forward to this chat with Jordan.
Well, so am I. And for those out there, today we're going to look back at our landmark project, Ascent, in Milwaukee. It's currently the tallest mass timber building in the world. And we're going to try to understand a little better about what it's taught us.
So today to talk about Ascent, we're joined with our colleague, Jordan Komp. Jordan leads our Milwaukee, Wisconsin office and has designed structural systems for tall and super tall buildings all around the world, as well as several mass timber buildings, including Ascent. He's a member of the Wisconsin Department of Safety and Professional Services, Tall Mass Timber Task Force, and he's also a mass timber special inspector. So excited to hear all he's learned through that experience, and welcome, Jordan.
Thanks, Kristina. Thanks, Paul. I'm happy to be here. Thanks for having me.
Okay, Jordan, so let's just get right into it. Let's start talking about Ascent, the building itself and its significance in the mass timber world. What made it groundbreaking? How should we open the door with this discussion?
Yeah, absolutely. I think it's no secret to anyone, right, that at least prior to Ascent, and really honestly, probably still now, mass timber throughout the United States is a bit behind the rest of the world, specifically sort of Europe and Canada. We're catching up very quickly, but I think really it stands as a point in time for the United States. I don't think it's a coincidence if you look at IBC 2021 that you look at the Type 4A construction, that it's 18 stories of concealed construction, right? Though whether or not it's good, bad, or otherwise, Ascent will be a precedent for all other tall mass timber and really mass timber work in the United States and potentially throughout the world.
So, Jordan, you've tackled a lot of new areas in designing Ascent. One of the areas is the code process, right? To get a tall mass timber approved with a certain amount of exposed wood. Maybe you could tell us a little more and walk us through some of that code approval process and the work that Jordan Tomasetti did to facilitate that.
Yeah, absolutely. In terms of technical challenges on Ascent, really sort of driven by this idea of vertical compensation and sort of lack of existing information associated with it. So in terms of that, we sort of have looked at past research, things we had found, our own analysis, and sort of found that from a compensation standpoint, that a mass timber building is going to sort of move, let's say, or need to be compensated for equivalent to a concrete structure of 3 times the height, right? So if you had a 25-story mass timber structure, you're looking at about a 75-story concrete. That's sort of the equivalent comparison.
So,
And then
Jordan, just let me jump in here. Just to clarify that point, you're talking about elastic shortening and what happens as these timber members compress over their height and under the load that they're under.
Correct. So you're going to have your elastic and you're going to have your long-term and shrinkage and shortening due to moisture. So there's a lot of factors, and they all happen at potentially different times. So it's important that it's not only just an engineering challenge or a structural engineering challenge, but that the MEP team is on board, right? That the window wall manufacturer is on board so that everyone understands these movements. It's not just that the structural engineer understands them, but all the systems and parts and pieces and components of the building are really included in those movements, and they understand that, right?
Jordan, what I'm hearing you explain is that with a mass timber building, because of maybe nuances, because of a newer building material, because of getting all the parties involved up to speed, there needs to maybe be a deep involvement of the structural engineer to help inform, guide, and direct the project in the direction that it needs to go in order to be efficient to be approved, to be cost effective.
100%. That's absolutely correct. And we as structural engineers, I'll say sometimes we like to stay in our lane, so to speak, right? We
Yeah,
like to say this is
right.
our job, this is what we do. Fire protection, that's not me. Architecture, this is somebody else. So absolutely, while there may be a fire engineer, there may be other connection engineers, there may be other detailers. Really, for this project to succeed, you need a designer, a structural engineer that has experience with mass timber, and in this case, tall mass timber, that can sort of be involved in these conversations at a minimum, and to be a part of that conversation.
Yeah, I'm definitely seeing mass timber as an area where the role of the structural engineer has been increased to include more code related topics, fire protection, building types, areas. It seems that we're taking on, I don't want to say more of that role, but at least having an important role in those discussions.
And that sort of leads into one of the critical, aspects of the design is also constructability, right? Is a pre-construction, they're going to throw a lot of money at it for uncertainty, right? So the more you can do with these designs to keep them simple, well understood, give the contractor confidence that they can construct these, the better bet you're going to have to sort of minimize that quote unquote uncertainty factor. And you're going to get sort of something that's more in line with the budget you need, which, because mass timber project no different than any other project in which it needs to be cost competitive and meet whatever the owner's pro forma is. But back now to Paul, your original point about the approval process, right? I think what we can learn from Ascent, or what we can take that's really still applicable for every project, is it's very likely that you'll at least consider, if not need, some type of variance, right? Whether it's for area, occupancy, height, something, concealment, whatever it is. This idea of a variance for mass timber is not necessarily going to be unique to Ascent. It'll be very common, I think, for quite some time here with tall mass timber, is sort of the IBC and the approval and the code process catches up with the knowledge we do have, as then we gain more testing with mass timber. I think if you look at, for example, IBC 2021, when that came out, there was a motivation to have tall mass timber in the code. And I think anyone that even approved it would acknowledge, is it perfect? Absolutely not, right? But it was conservative, and it was that people felt confident that they would be able to get it approved in a timely manner. As I mentioned with Ascent earlier, now it's a data point. Now tall mass timber is at least in the code. We can refine it and approve it moving forward. But that's all part of the process. So in terms of Ascent, we were still actually under the Wisconsin Commercial Building Code, which was using at the time IBC 2015. And sort of what that meant is, to get this approval or this variance, we were using sort of the alternate materials provisions. And so that was sort of the baseline of the variance we had, which was sort of essentially showing equivalent performance in this condition. That meant fire resistance for a non-combustible material. We got really lucky with Ascent. We had the AHJ, or authorities having jurisdiction, that had a history in forestry, right? So they were supportive of this process from the start. We also coincidentally had the National Forest Products Laboratory located in Madison, Wisconsin. They were actually able to do for us some 3-hour column tests, which I believe were the first in the world. So we had a lot of things going in our favor. We also had one of the sort of the lead thought experts in firefighting throughout the country, also coincidentally located in Milwaukee, Wisconsin. So we really had sort of all these stars aligning, and they were all brought in early. And really, as a part of that, made sure that they were comfortable with the process we had in place.
So Jordan, as engineers, we do all of our homework. We try to have all of our ducks lined up, but I'm sure there were some unexpected hurdles and some issues that came up. I'm just curious if you might share a couple of those and maybe how you resolve those.
As mass timber is new in the industry, there aren't maybe the quote unquote field fixes or things, typical details that are sort of in place for other conditions, right? If you're concrete, if they overpour, they chip out and they do this and they grout it, and that is what you do. We, at least at the time on Ascent, we didn't have a lot of these. So I remember the contractor getting a call early on where they said, to meet the schedule, we need to set a piece of mass timber every 7 minutes. So they would come in and say, oh, this rod wasn't installed in the factory correct, or the screw isn't here. What do I do? And it was like, well, I don't know. I can't give you an answer in 7 minutes. I need to see a picture of it. And so you have till the end of the day to give us this answer. Otherwise, you're going to delay the project. That was sort of the tone, but we got pretty good. We got lucky that we provided the special inspections for the project. So we had someone on site nearly full time that they could in real time give us feedback. We could take that, and I remember my colleague Alejandro and I overnight, we would take the feedback throughout the team on site all day. And then from 8 to 10, we'd have a meeting every night. We'd come up with the fixes. We'd send them in the morning. They'd have their morning meeting. I'd go up to site at 6 in the morning. We'd tell them how they're going to fix it. They'd fix it and we moved on. So yeah, to your
Wow.
point, yep,
Wow.
things happened and it was just sort of being a part of a team and collaborating in real time to make sure to get them the responses they needed.
Well, that's quite a dedicated schedule you guys kept.
There were a
It's
lot of
impressive.
dedicated,
Did you
yeah.
eat? Did you sleep?
There were a lot of
Did you see your
dedicated team members
family?
on this
Yeah.
one. Yeah.
Yeah. So that's just what
Yeah.
it takes.
Hey, I wanted to maybe transition a little bit into the lessons learned and how we're taking those lessons as a company, right? And translating them into the broader tall timber work and just general timber work that we do. Or how have you influenced, or you're seeing the influence of scent impact the rest of Thornton Tomasetti's timber work?
Oh yeah, absolutely. So I would say one of the things we really learned is through the detailing process on Ascent, right? TT was heavily involved in the design and we did all the connection design of the mass timber elements. Because what we saw is even with this design, how tight things fit together. Every single screw and rod and anchor and how tightly fit these are and sort of the fabrication tolerances, right? We're talking millimeters on a lot of these pieces.
Hmm.
And what we learned is when you sort of fit them up, it's one thing to design the member, right? It needs to be this big, this wide. But it's another thing to figure out, does this work with the connection? Does the connection actually fit? And that's before you consider fire ratings of these connections. And so what we learned is that if you don't have the same person detailing the connection that did the design, at a minimum, there's a lot of challenges and potential hurdles there where members work for strength but not connections, or you're sort of modifying things that could, you know, impact architecture. It's really sort of this interaction of designing and detailing, which is not the same as say a steel structure where it's like, well, there's 3 or 4 bolts, right? That's sort of the difference. These two are sort of inherently tied, and it's very hard to separate them.
It's exciting to see your involvement in some of the upcoming tall timber projects. And I've heard a lot of excitement and interest in hybrid systems. I'm curious, is that based on your experience with Ascent, or what do you find about hybrid systems that's an efficiency or something exciting about where tall timber can go?
Sure, absolutely. I think it's no different than any other material, right? When we're talking either composite steel construction, right? We've always wanted to use the right material for the right solution in the most efficient way possible. So as whether it's the concrete slab with the steel below, the steel gives the long spans, but then the concrete gives additional strength. Um, that sort of thought process in mind, right? People have been trying to get composite action on mass timber almost since the start, right? Whether it's screws or anchorages or how you're going to do this with shear keys, it's always been something we've been trying to look at. And so one of those is one where you're actually utilizing the CLT as a finished product, but also sort of as formwork, right? So you're utilizing this in the temporary condition. You're going to have, if you were doing a concrete structure, formwork anyway, you're going to need it. So seeing if there's a way to sort of leverage that to get, even without composite action, the difference between this sort of the CLT and concrete and utilizing the system. Because I think depending on the material costs and things like that, where sometimes concrete can be, more cost effective for certain scenarios. So trying to use both for their optimum efficiency, right? We want this beautiful exposed mass timber, but utilizing any efficiencies we can get from the concrete, whether that's fire rating, easy to construct, whatever it is, but trying to use both of them for their optimal, efficiency.
Jordan, you talked about cost here a couple times. I know on Ascent, and I think we all face this. There's a early costing on a project. Then there's maybe a refined price cost of the timber once you have more detailing. But in your experience, what's a better way to procure and or direct the procurement of the mass timber? I know in a sense you had some refinement of pricing as you guys got involved. Maybe you could fill in a little bit of the gap there.
Our first cost estimate was right around $75 a square foot for the mass timber. I think the final number, which was $42 a square foot, right? So you're looking at, 50 to 60% of the cost. In that case, I think a lot of it just had to do with being able to take a tall mass timber building in the United States seriously. But I think where you were leading to, Paul, and I think that's absolutely critical, is we absolutely need to have good design drawings early on, right? Like it's critical when you go to these manufacturers, particularly for tall mass timber, where you could be taking up a lot of their capacity for a year or more. So
Mm-hmm.
for them to sort of understand and believe in the design to give you a real price, or that they can at least see that it's well thought out, that you're giving them a design that has all the right parts and pieces, that gives them the information they need, either the actual design and layouts and drawings, or quantities, cost estimates, things from past research where they can look and say, we believe we can see why this is going to get built. This makes sense. But you have a team in place that knows what they're doing, has shown the right things, are considering the right things, maybe even asking the right questions. They want to use their systems, right? They want it to be as efficient as possible. They don't want to make it more expensive than it needs to be. So I think it's just giving them something, showing that expertise so that they can give you the best price possible.
That's so interesting because we've probably touched on every episode here the importance of partnership and partnering with the supplier and the fabricator and working as a team. But I never really thought about what it looks like to establish confidence between the teams early on, right? Like any relationship is like built on trust, and how do you set yourself up that the fabricator supplier is going to trust you to work as a team, but maybe even brings to light for tall buildings. And I hadn't thought about that, but the sheer volume that they're committing to, right? And the amount of time probably that you spend on the phone with this person that you team up with too, right? Is like such a critical piece of the partnership that we hadn't really talked about.
Yeah, and that's really why I think too that the US, they had some work, but they're going to catch up as we continue to get sort of additional manufacturing capacity in the
Yeah.
United States. When we're talking Ascent, the wood came from Austria, from Europe. Part of that was they just have this long history of they had the capabilities to do this, right? Again, they had a beautiful product. The Austrian spruce was beautiful. The owner fell in love with it, but also they had the capacity there to do it, right? Not only did they have their own forest and they were running that, they had the parts and pieces in place where they were big enough to handle I'll call it the risk associated with this potential project, and sort of the capacity and materials in place to utilize this. Whereas a lot of the smaller manufacturers in the US, they would have been putting their entire manufacturing process on the line for this project, which I think would have been a bit more of a risk versus sort of the European ones that were a little further along and more developed.
Jordan, I got a couple questions that I think everybody would be curious about. And one is, you've had a lot of experience. What's one piece of advice that your team could share with other professionals looking at starting a tall timber project?
Yeah, absolutely. I think to have a successful project, you need early buy-in from everyone, and that's top down. So you need to have an ownership group that is committed to mass timber. Every project I think now I've on steel, concrete, otherwise, we at least look at mass timber early on, right? It's at least something that's considered. But having an owner that's committed to it, that's going to let the design process play out, or at least get those drawings to a position where we can actually get meaningful input from the rest of the industry, because then you need buy-in from a contractor or fabricator that, I'll say, just like the design team, knows what they're doing, has been on it before, can confidently bid on the project, so there's not that sort of uncertainty factor that you're sort of fighting for the rest of the project. And then obviously the design team, incumbent on them to get a good design that is efficient, that's simple, that's well understood, that can be constructed. So I think my advice would be to make sure that everyone is knowledgeable and comfortable with the process and committed to mass timber.
All right. Well, that's what we strive for sure. So, all right, one final, put you on the spot. How tall can we go? How tall can we go
Ooh.
in mass timber?
I don't think it's a question of an engineering question. I'll say that, right? I think it's going to come down to cost, right? That's, I think, where it is. And even from a variance approval process, we can always make the mass timber bigger. We can use hybrid structures. We can do those things, but that'll come at a cost, right? We're going to continue to do research to sort of validate this from a code perspective, but it has to pencil out at some point. Otherwise, no one's going to want to build it.
All right. Well, let's start saving our pennies so we can build them taller.
You got it. Thank you guys so much for having me. It's been a pleasure.
Hey, Jordan, thank you for joining us and for sharing all your insight. And, I look forward to applying all the lessons learned and seeing how tall we can go. So thanks a lot.
Absolutely. Yep. Thanks,
And,
guys.
and thank you, everyone, for joining us on today's podcast. And we'll look forward to seeing you again soon. Thanks a lot. Bye now.
Tune in for our next episode, Better Options for Mass Timber Procurement, and like, subscribe, follow, or comment.